This video is going to go over year 5 of Unit 4, which is graphing your reciprocal functions. The first thing that we always do whenever we get a new graph that we need to be able to graph for our tests or for anything is to make a t-chart of our parent function so that we have an idea of what every single graph should look approximately like. So what we're going to do first is just graph the most basic reciprocal parent function. And that for us is going to be just applying the reciprocal to your typical y equals x graph. So it's going to be f of x equals 1 over x. And so that's what we're going to graph here, just seeing really what happens when our x is in our denominator instead of in our numerator. Like I said a minute ago, we always start by making a t-chart. And we always start with just our typical -2, -1, 0, 1, and 2. There's nothing, there's very few things that you can't divide by. And so most numbers are going to be able to work in this. One thing that we cannot divide by is this 0 right here in the middle. Okay, if you do that, that gives you 1 over 0, which is undefined. And so we can't divide by that. So that's going to cause something interesting to happen on our graphs that we're going to talk about in just a minute. But if we type in the rest of these numbers, this does work. So 1 over 1 gives us 1. 1 over 2 gives us 1/2. 1 over -1 gives us -1. And 1 over -2 gives us -1/2. So if I go to plot those just to see really what's happening, -1 is at -1. -2, -1/2. 1 is at 1. And 2 is at 1/2. And we know that we can't plug in 0. So, oopsies. Something funny is going to be happening in this middle part here. But right now, if we look at this, we still really don't know what's happening with those 4 points. And so what I would tell you on your parent function is to plug in more stuff. And what we're going to start by doing is plugging in numbers on the outside. So I'm going to try to go this way and plug in things bigger than 2 and bigger than -3, the absolute value. So for example, if I plug in either plus or minus 3, we should get plus or minus 1/3 based on the number. If I plug in maybe plus or minus 8, 1 over plus or minus 8 is just going to still be plus or minus 1/8. Okay, and so these are going to get slowly closer and closer and closer to that x-axis, or the line y equals 0. But what I want you to think about is whether or not they will ever actually touch this line here. No matter what you plug in, whether it's 100 or 100 million, 1 over 100 million is not quite 0. It's going to be awfully close to 0, but it's never going to be 0. It's also never going to be negative. So our graph has this line here that it's approaching, and that line is called an asymptote. An asymptote is a line that the graph approaches but never touches. It's mathematically impossible to get that value out. In this graph, one of our asymptotes is this x-axis, or the line y equals 0, because our graph will never touch that line. It's going to approach it. I'm going to draw in just the outside portions of this graph. It's going to approach it, but it will never actually touch it. So I typically draw in my asymptotes with like a highlighter or something, just a different color, that way you don't get it confused with your axes. So here we have this horizontal asymptote at y equals 0, because again, you can never get 0 out as an answer, and it will certainly never suddenly be negative. So I always draw in that asymptote and then do my best to make it look like it's never going to cross that line. If you draw the asymptote and you do your best, I will know that that shouldn't cross. Okay? So we now have a pretty good idea of what's happening to the far left and the far right, but we still don't really know what's going on in here. Okay, so if we plug in a number in between this -1 and +1, say plus or minus 1/2. When you do that, that gives you a complex fraction. And if we multiply by our LCD, those will cancel and we get 2 over 1. So this is at plus or minus 2. If you plug in 1/3, you get plus or minus 3, and so on. We already know we cannot plug in 0. So like we discussed a minute ago, because we mathematically can't do it, it's going to give us an asymptote that my graph's going to approach. So I have this asymptote at 0, but my graph is going to go up and get closer and closer and closer to 0, because I can plug all those numbers in up to 0 on either side. I just can't plug in 0. Okay, so this is what our graph will approximately look like every single time. It's going to have two different asymptotes that it's going to approach in both directions, and it's like you see here, going to be in two different spots on your graph entirely. Okay, so if we start to fill in our characteristic chart, my domain is everything except for 0. Again, this 0 gave us our vertical asymptote. And so I can fill in my domain as negative infinity to 0 and 0 to infinity. So again, this came from your vertical asymptote, was the only thing x cannot be. Your range needs to tell me everything y can be, which means it's helpful to think about what it can't be. And the only thing it can't be in this example is your horizontal asymptote. So in this case, it's going to be the same as my domain, but it will not always be. But it will always be tied to your horizontal asymptote. Today we don't have any holes. You will have them next time, so we'll talk about in detail what to do with that later. But in today's problems, they won't show up. As for our limits, typically we go to our domain and we pull those down for our x values right here. But in this case, we have more numbers. So I want to talk about really how we deal with that. In the middle here, as it approaches 0, so this middle number, you'll notice that it approaches two different things, and that's called really your left hand and right hand behavior of your limits, and that's something you're going to talk about in calculus. So here in Algebra 2, we are not going to worry about that one, and we are strictly going to think about the outsides. So it is possible to give a limit in the middle or to discuss the characteristics and things like that, but we are not going to do that here. So what you are always going to do for these is just give me negative infinity and infinity, and then think about what it's approaching. As we go to the far left, so as we go to negative infinity, my graph is going to keep growing, but it has this ceiling. So it is never, ever, ever going to cross this line y equals 0. So it's going to forever approach f of x equals 0, which is the same as y equals 0. Going to the right, you'll notice the same thing happens. Again, it's going to get closer and closer and closer to this floor now, but it is never, ever going to cross it. For increasing versus decreasing, this one can confuse some people. As you look at it, strictly going from left to right, this graph is only decreasing. It will never increase. So we're going to write none for increasing on this one. And the decreasing is my negative infinity to 0 and 0 to infinity. In this example, for an x-intercept, it's never going to cross that line, so it's none. And the y-intercept, same idea, it's never going to cross that horizontal or that vertical axis, so it is also none. So remember, this parent function we will use to make sure that our graphs are looking the correct way and as an idea for what our chart should look like. We are going to start moving this around though, so this will not be what it looks like the rest of the time. Exactly, because it'll move around. Okay, we're going to talk about our standard form or your transformation form of this, because again, it wouldn't be Algebra 2 if we weren't moving this around. And the form looks much like everything you've seen with all of our other graphs, but now your a, h, and k are just in your reciprocal function instead of in any of the other ones. And so we're going to remind you what a, h, and k mean, but these are things that you have done all year long. Okay, that a value up top will either stretch, shrink, or compress, whichever way you prefer it, or reflect your graph. So it will stretch it if your a value is greater than 1. It will shrink it if your a is between 0 and 1. So if it's a fraction less than 1. And it will reflect if your a is negative. So I'll flip it over. Your h value will translate left if you see a positive, because again we plugged in a negative, so it would be x minus a negative, which gives me a positive, or right if you see a negative. And your k value will translate up if you see a positive, because we would have moved it +3, so that will just stay +3, or down if you see a negative. for our asymptotes, we can actually get it from these equations exactly. Okay, if you move your graph left or right, let me see if I can do this for you. If I move it to the left, the asymptote is that has changed. My horizontal asymptote stayed the same, but it's my vertical asymptote that changed. And that's going to be very important. Let's see if I can line this back up. Okay, and then if I move it up, whoopsies. My horizontal asymptote now has changed, but my vertical has stayed exactly the same. And so that's going to come in to be very important. Close enough. Here. So the left and right, if you remember, moved my vertical asymptote. So my vertical asymptote is always at x equals h. This also really just comes from your excluded values that we have talked about all chapter long, where you would set your denominator equal to 0. And if we solved this, we would get x equals h. So it's the things x can't be, so it's our excluded values. Your horizontal came from moving it up and down, so that's always at y equals k. Okay, what I want to make sure you remember real quick is how to write an equation if you're given a description. So go ahead and write this down, give it a try, and then unpause it when you're ready. But you're going to plug this information into your standard form to write an equation for it. Okay, so assuming you've had some time to think it through, and if not, remember, just pause the video. We're going to go through this paragraph and fill in everything where it goes. For my a value, again, that would be a stretch, a shrink, or a reflect. And here it tells me it was reflected across the x-axis, so I know that that 8.5 value needs to be 1. Nowhere in this paragraph does it mention a stretch or a shrink. So we don't know that it wasn't because it doesn't definitively say it wasn't. So typically I do put a 1, but I will not count you wrong if you tell me it's -2 because it would still follow the characteristics listed. For my h value, that needs to be something that went left or right. And in here it went 4 units to the right. So I plug in a +4, so it looks like an x - 4. And then my k is my up or down, so that's the 3 units down. So I went -3. So that would be the equation based on that description given to you. For your asymptotes, again, your vertical asymptote is always your x equals h, or you can solve this bottom equation because it will be excluded values. So in this case, it's at x equals 4. And my horizontal asymptote is always my y equals k or y equals -3. I always start my problems by finding my vertical and horizontal asymptotes, which is why I had you do it here. Always being able to look at your equation and identify it will be very important moving forward. I'm going to go ahead and give you some steps for how to graph and then work through a couple different examples so that you can see how this will work out. As I alluded to a second ago, the first thing I would always do is identify your vertical asymptote and your horizontal asymptote. You'll notice that in the parent function, everything was kind of centered around those asymptotes. And so if I can find those right off the bat, I know where the middle of my graph is going to be. And it will help me to go from there. Then I'm going to create a t-chart. And you can arguably plug in anything you want except for your vertical asymptote. And so I use that. I'm going to center my t-chart on that vertical asymptote. So I'm going to put that dead middle of my graph so that I can go on each side and know I get things in both pieces of the graph. Because remember, again, your graph shows up in 2 different locations. So you want to be able to find things in each location. Then you're going to graph it. And lastly, like always, we're going to do our characteristic chart and make sure you can tell me all about the function. Okay. I'm going to jump to a more complicated one just to give us plenty to talk about here. So go ahead and write this one down, get your notes ready, and then pause the video, or play the video whenever you're ready to actually talk it through. So the first thing we're going to look at is our asymptotes. We need to find our vertical and our horizontal. Remember, your vertical always comes from your h value or from your excluded values. So here my vertical is going to be at x equals 2. And my horizontal comes from my k value. And so it's going to be at y equals, negative 2. What I do is I draw those in. You can draw them in right away. You can draw them in later. But I like to know where my graph should be centered around. So again, I'm going to go to 2. I'm going to go to negative 2. You can just draw dashed lines. You can use a highlighter, whatever makes you happiest. And I know that my graph should be showing up right around this somehow. I don't actually know how yet, but I know it should be in that area. And that's going to give me a good way to check my numbers as I plug them in. So when I go to my t-chart, I always take my vertical asymptote, so in this case 2, and I put it in the middle. It doesn't have a y value, so I just cross it out. But again, I want my vertical asymptote to be the center of my graph, and so I put that number in the center of my t-chart. And then I'm going to plug in things both on the left and on the right. So on the left, I'll do like 1 and 0, and on the right, I'll do 3 and 4. When you're plugging it in, I will write it all the way out this time, but you do not have to write out every number once you're comfortable with evaluating. On the same note, if you need to write out every number every time, do it. So when I'm plugging it in, I'm going to plug in the number for x each time. And then I'm going to go ahead and evaluate these. So in this first one, 0 minus 2 is negative 2. So I'm really doing 3 over negative 2, which is negative 1.5 or negative 3 over 2. You can keep it as a fraction or a decimal. And then when I subtract 2, I get negative 3.5. Or again, you can keep it as negative 7 over 2, whatever makes the most sense to you. For the next one, 1 minus 2 is negative 1. 3 over negative 1 is negative 3, and negative 3 minus 2 is negative 5. Going now to the other side, 3 minus 2 is 1, so this is 3 over 1 or just 3. 3 minus 2 is 1. And then lastly, 4 minus 2 is negative 2, so it's 3 over negative 2 or negative 1.5. Over positive 2, sorry. So it's positive 1.5. Minus 2 gives me either negative 1/2, or you can write it as negative 0.5. And so I'm going to go ahead and plot these where they belong. And like we did on the parent function, you are welcome to plug in more points. But because we know what this should look like, you don't have to. We know that it should be approaching both asymptotes after it goes through those 2 points that we plotted. And so we don't need more unless, again, you forget your parent function or something like that. So that's what our graph will look like here. It's stretched a little bit more because of this 3. That's why it gets taller faster. And it was moved to the right and down. So it does fit our characteristics, which is good. Going to our chart. Again, your domain is everything except your vertical asymptote. So in this case, it's negative infinity to 2. And 2 to infinity. My range, every y value that it can be, so it's everything except for whatever your horizontal asymptote is. So it's negative infinity to negative 2 and negative 2 to infinity. Today, again, we won't have holes. For your limits, you're going to use your left and right. And so this will be f of x. On the left, it's approaching negative 2. And on the right, it's also approaching negative 2. Typically, these will match. Again, as we get to more complicated ones next time, they will not always match. This graph is only decreasing, so I'm going to put none. It's going to be negative infinity to 2 and 2 to infinity. I'm going to skip to y-intercepts real quick because we actually already did that one. Y-intercept is when you plug in 0 for x, and so we did it over here. And we plugged in 0, so I can just cheat off myself. Again, you can write it as a fraction or a decimal in your graph, so either is fine. To find my x-intercept, though, this is where you need to set it equal to 0. And we're going to use the solving skills that we've practiced the last few days. One thing you can do, you can multiply this entire problem by your LCD right off the bat, but I also notice that I can move this -2 to the other side. And if I do that, I just have a fraction equals a fraction, because this 2 is really over a 1. And then I can just cross multiply, and the problem's a little bit more easier for me. But however you choose to do it is fine. When you solve this, you get 2x minus 4 equals 3, and you end up getting 7 over 2, or 3.5. Remember, when I do these, I always check and make sure that it matches with my graph. So 3.50 looks about right based on the graph. Again, there's always human error, but as long as it is a logical number that it could be, it helps you to know that you're probably on the right track. Okay, we're going to go ahead and do one more. I'll do a different one than the one we did in class, just to give those of you who are using this for practice help there. I'm going to make this a negative, and we'll make this a +2 to make it a little bit trickier. If you want to use this as practice for yourself, feel free to go ahead and just try it and then check it when you're done. If you want to just hear me talk through it, that is also totally fine. Okay. So again, I find my vertical and horizontal asymptote first. Your vertical comes from your excluded values or from your h value. Your horizontal comes from your k value. So my vertical here is at x equals -3, and my horizontal is at y equals 2. Again, today there are no holes, and I am going to go ahead and draw this. So x equals -3, y equals 2. And then I'm going to make my t-chart. -3 is going to go in the middle because that's my vertical asymptote. And then I'm going to plug in things left and right. So -4, -5, and then -2, -1. If I just go down the row and plug them in, plugging in -5, that gives me a -2. So this is -1 over -2, or +1/2. So it's going to be 1/2 plus 2, which is 2.5. And again, you can write that as a fraction. It would be 5 over 2. Either way is fine. When I plug in -4, -4 plus 3 is 1. Or sorry, -1. And do -1 divided by -1 gives me a +1. So it's 1 plus 2, or 3. Plugging in -2. -2 plus 3 is 1. So -1 over +1, this stays a -1. -1 plus 2 gives me 1. And then lastly here, when I plug in -1, that gives me -1/2 for this entire first fraction. -1/2 plus 2 is 1.5, or again, you can write it as 3 over 2. And then we're going to go ahead and plot these. So at -5, I am at 2.5. Oopsies, got a little far off. At -4, I'm at 3. And so the left side of this graph looks something like that. And then the -2, I'm at 1. -1, I'm at 1.5. And the right side of my graph looks like this. This is flipped or reflected from our previous one and from our parent function, and that all leans on the fact that this is a negative right here. So that makes perfect sense for us in this scenario. To go ahead and do the chart, the domain is everything that your x can be, and the only thing my x can't be is -3. So it's going to be -infinity to -3 and -3 to infinity. Range is everything y can be, so you just got to think about what y can't be, which is your horizontal asymptote. So -infinity to 2 and 2 to infinity. On the left side of my graph, it's going to be approaching 2, because over here it's going to reach that floor. On the right side of my graph, it's also approaching 2. Again, typically today these match each other. As for increasing and decreasing, this is a function that is increasing. Everything's going up as you go left to right. So it's going to be -infinity to -3 and -3 to infinity, and then none for my decreasing. For my x-intercept, I'm going to set it equal to 0. And again, you can move that 2 and then cross multiply. So I'm going to have negative 2x minus 6 equals negative 1. That gives me negative 2x equals 5, and x equals negative 5 over 2, or negative 2.5. Again, the very first thing I check with this number is, does that match where it actually crosses? And it does appear to match, which means I'm probably on the right track. For our y-intercept, we did not plug in 0 yet, so I'm just going to add a line in my chart. This is going to give me negative 1/3 plus 2 when you plug that in, which is going to be 1.6 repeating, or 1 2/3. Again, looking at the graph, that seems about right.